Somewhere in the ant colony living beneath a fallen log in your yard, or tucked into a sunny patch of your lawn, there may be workers who were never actually born there. Ants who spend every day of their lives foraging, feeding larvae, and defending a nest that isn't theirs, protecting a queen they share no relation to, raising offspring that will one day be sent out to do exactly what was done to them. Capture the next generation of unwilling workers from a completely different colony. This isn't a metaphor, and it isn't an exaggeration for dramatic effect. It's a well-documented, scientifically studied survival strategy found in several ant species around the world, one so effective and so specific that entomologists have spent well over a century studying exactly how it works, how it began, and why the ants being taken never seem to realize anything is wrong. Today, we're going to look at exactly how this happens, from the raid itself to the years-long deception that follows, and why the next time you see two different-looking ants working side by side in the same nest, you may be watching one of the most unsettling relationships in the entire natural world. The process begins not with the ants who will become captives, but with a colony of a specialized species that has, over evolutionary time, lost the ability to perform many basic survival tasks on its own. Several ant species, most extensively studied in genera like Polyergus, along with certain Formica species, have evolved into what researchers call obligatial parasites, meaning their colonies cannot survive without regularly capturing workers from other, unrelated ant colonies to perform the labor their own society depends on. A raid begins when scout ants from the parasitic colony locate a nest belonging to a suitable host species, typically a smaller, closely related species in the same general genus. Once a target colony is identified, the parasitic colony mobilizes a raiding party, sometimes numbering in the hundreds, that marches directly to the host nest, often along a scent trail laid down by the scouts during their initial reconnaissance. What follows is a coordinated assault focused on a very specific objective, and it's not what most people assume. The raiders are not primarily interested in killing the host colony's workers or in stealing food. Their target is the brood, specifically the pupae, the developing ants still sealed within their protective casings, in that critical late stage of development discussed in earlier videos on this channel, where transformation into an adult is nearly complete but has not yet occurred. Raiding ants fight their way past the host colony's defenders, who in many documented cases put up a fierce, costly defense, and seize as many pupae as they can carry, transporting them back to their own nest in a single, often brutally efficient operation that can be over within an hour. This is the detail that makes the entire system work, and it's also the detail most people find hardest to believe when they first hear it. The captured ants never rebel, never attempt to escape, and in the vast majority of documented cases, never show any behavioral sign that anything unusual has happened to them at all. Understanding why requires understanding exactly how ants recognize members of their own colony in the first place. Ants do not recognize their nestmates by sight, and they do not recognize them through any process resembling memory or individual recognition the way a mammal might recognize a family member. Instead, colony identity in ants is established almost entirely through a shared chemical signature, a specific blend of cuticular hydrocarbons, waxy compounds coating the exoskeleton, that develops through constant physical contact between nestmates and through exposure to the specific chemical environment of a single nest. This blend functions as a kind of colony-wide password, checked constantly through antennal contact whenever two ants encounter each other, allowing a colony to instantly distinguish a nestmate from an intruder. Here is the critical vulnerability this system creates. Pupa captured before it has fully emerged as an adult has not yet developed any chemical identity of its own. It is, in a very real sense, chemically blank, a clean slate waiting to absorb whatever colony scent surrounds it during the earliest hours after emergence. When a stolen pupa finally completes its development inside the parasitic colony's nest, surrounded entirely by the chemical signature of its captors, it is groomed by the very ants who orchestrated the raid, and absorbs their specific chemical blend as its own colony identity, with absolutely no biological mechanism available to recognize this identity was never rightfully hers to begin with. From that moment forward, the ant genuinely believes, to whatever extent an ant can be said to believe anything, that she is a member of the colony she was raised in. She will groom the queen who had no part in producing her. She will defend the nest against intruders, including, in a particularly striking irony documented by researchers, sometimes helping to defend against raiding parties from her own original species. She will forage, feed larvae, and eventually, in species where captured workers participate in raiding behavior themselves, she may even take part in raids against colonies of her own original species, capturing pupae to be raised exactly as she was, continuing a cycle she has no biological capacity to recognize as anything other than normal colony life. Perhaps the most extraordinary detail in this entire system involves what has happened to the parasitic species themselves over evolutionary time, because in the most extreme documented cases, the dependency runs so deep that the parasitic colony has genuinely lost the physical and behavioral capacity to survive without captured labor at all. The Amazon ant, a species in the genus Polyergus studied extensively by myrmecologists, represents one of the most striking examples of this. Polyergus workers have evolved mandibles specifically shaped for combat, sickle-like and highly effective in raids, but so specialized for this single purpose that they are physically incapable of performing many basic colony tasks. They cannot effectively feed themselves, relying entirely on captured workers to provide food through direct mouth-to-mouth feeding. They cannot efficiently forage for food outside the nest. They cannot, in most observed colonies, even care for their own larvae without the labor of captured workers managing that process for them. In practical terms, this means a Polyergus queen, upon founding a new colony, faces an almost impossible task without immediate access to captured labor. Research on how these colonies are actually founded reveals an even more unsettling layer to this story. A newly mated Polyergus queen typically cannot start a colony from scratch the way most ant queens do. Instead, she must infiltrate an existing colony directly, in many documented cases killing the host's own queen and taking her place, relying on chemical mimicry to avoid detection by the host workers during this takeover, before beginning to produce her own offspring, who will then be raised and fed entirely by the host colony's surviving workers until enough of her own daughters have matured to begin conducting raids and replenishing the captured workforce on an ongoing basis. This means the entire multi-generational existence of a Polyergus colony depends at every single stage, from its violent founding to its daily maintenance, on the labor, and in the founding stage, on the literal lives of an entirely different, unrelated ant species, a level of evolutionary dependency that goes considerably further than most people assume when they first hear that some ants keep slaves. A single successful raid solves an immediate labor shortage, but it doesn't explain how these mixed colonies, made up of the parasitic species and multiple generations of captured workers, continue to function smoothly over months and years without the underlying deception ever unraveling. This requires an ongoing, active process of chemical maintenance that researchers have only fully mapped in the past few decades. Colony scent is not a one-time stamp applied at emergence and then fixed permanently. It is continuously refreshed and reinforced through ongoing physical contact between nestmates, meaning captured workers are constantly reabsorbing and reinforcing the parasitic colony's chemical signature simply through the routine, repeated contact of daily colony life, trophallaxis, grooming, and general movement through shared nest chambers. This constant chemical reinforcement is precisely why a captured worker, even years after her original capture as a pupa, continues to register as a full colony member to every other ant she encounters, and why she herself continues to treat the colony as entirely her own. There's an additional layer of manipulation documented in several parasitic species involving direct chemical signals released by the parasitic queen herself, compounds that suppress aggressive or investigative behavior among captured workers, functioning similarly to the queen pheromones many ant species use to maintain general colony cohesion and suppress reproductive competition, but in this specific context, potentially playing an additional role in maintaining the stability from multiple, biologically unrelated populations. Researchers studying continue to refine exactly how significant this chemical influence is relative to the simple mechanics of shared colony scent, but the overall picture that emerges is one of continuous active chemical management, not a single deceptive event, sustaining what is, in effect, a permanent, multi-generational system of unrecognized captivity. It would be inaccurate to present this entirely as a one-sided story with no resistance at all, because the host species targeted by these raids have not remained passive across the evolutionary timescale this relationship has existed. Several documented adaptations suggest an ongoing evolutionary arms race between parasitic raiders and their preferred host species. Some host colonies have developed measurably more aggressive defense, specifically correlated with regions where parasitic raiding species are common, including larger worker populations concentrated in instances during the specific seasonal windows when raids are most likely to occur, a pattern consistent with a population-level defensive adaptation shaped by generations of raiding pressure. In certain documented cases, host colonies have also observed relocating their brood chambers during periods of known raiding activity in their region, a behavior that closely parallels the disturbance response relocation behavior discussed in the context of ordinary brood management, but specifically timed to coincide with the seasonal raiding patterns of nearby parasitic colonies. There's also evidence that some host species have evolved chemical signatures that are somewhat more resistant to being fully overwritten by a captor colony's scent, potentially reducing, though not eliminating, the success rate of the identity replacement process described earlier. None of these adaptations have eliminated it entirely, and the relationship persists across the specific regions where these parasitic and host species overlap. But the ongoing evolutionary pressure in both directions is a genuinely active area of research, illustrating that this isn't a static, one-sided relationship frozen in time, but a continuously evolving contest between two sets of species pursuing opposing evolutionary strategies. It's worth pausing here to explain why this particular relationship has drawn so much sustained scientific attention over more than a century, beyond simply being a startling fact to share. Social parasitism in ants, of which this raiding and capturing behavior represents one of the most extreme documented forms, offers researchers a genuinely unique window into questions about identity, recognition, and social cohesion that extend well beyond entomology. The fact that an individual's of colony membership, effectively her entire social identity in this context, can be entirely determined by chemical exposure during a narrow developmental window, with no underlying awareness that this identity was externally imposed rather than biologically inherited, has made this system a specific subject of interest in broader research on the biological basis of group identity and recognition systems across the animal kingdom. Beyond the theoretical interest, understanding these dynamics has practical value for broader pest management and conservation efforts as well, since social parasites can significantly affect the population dynamics of their host species in regions where both exist. In areas where a particular host ant species plays a documented ecological role, whether in soil aeration, seed dispersal, or serving as a food source for other wildlife, understanding the pressure exerted by a local population of raiding parasitic ants provides important context for anyone studying or managing that broader local ecosystem. To be clear and precise, since this is a detail worth stating directly, the specialized obligate social parasite species discussed in the most extreme examples above, particularly Polyergus, have relatively specific geographic ranges and host preferences, meaning most ant in a typical yard, including the foraging trails, peony guarding workers, and leaf-carrying colonies discussed in earlier videos on this channel, are not involved in this specific raiding relationship at all. However, several related, less extreme forms of social parasitism do occur more broadly across a wider range of ant species and regions, including temporary colony infiltration by a single parasitic queen, ongoing large-scale raiding, and less specialized species that occasionally supplement their own labor force through opportunistic raiding without the extreme physical dependency seen in the most specialized cases. If you're specifically curious whether a colony might show evidence of this kind of mixed species composition, the most reliable indicator, the one that generally requires closer observation than casual yard watching allows, is the two visibly different ant types working cooperatively within a single, shared nest and trail system, a genuinely distinctive sight that experienced observers of ant colonies do occasionally document, even in ordinary garden and park settings within the specific regions where these relationships are known to occur. Unlike most of the videos on this channel, this particular topic doesn't come with a list of direct action steps for your yard or garden. Since this behavior involves a relationship between two other ant colonies entirely, not a direct interaction between you and the ants in your own home. But there is a practical takeaway worth carrying forward. First, reconsider the assumption that all ants within a single visible colony are automatically closely related to one another. As covered throughout this video, colony membership in ants is fundamentally a chemical and social construct, not strictly a genetic one, a detail that reframes how you might think about ant behavior more broadly the next time you're observing a trail or a nest. Second, if you do notice two distinct types of ants moving together or working on the same nest entrance, particularly in regions of the country where polyrgous and related hosts be minted, this is a genuinely rare and scientific observation worth documenting, ideally through respectful distance, and potentially worth reporting to a local university department or a citizen science plant observation, since detailed field sightings from the public have historically contributed meaningfully to researchers' understanding of exactly where these specific relationships occur. Third, avoid disturbing any nest you suspect might be involved in this kind of relationship, for the same reasons discussed in earlier videos about brood piles generally, but with the added consideration that a mixed species represents a genuinely uncommon research subject that a casual disturbance could unnecessarily disrupt. What plays out in these raids and in the quiet, unremarkable daily life of a mixed colony afterward is one of the more genuinely unsettling examples of how evolution can shape not just physical traits, but the very mechanisms an animal uses to understand who it is and where it belongs. A captured worker ant spends her entire life in complete, biologically enforced ignorance of her own origin, faithfully serving a colony that began, for her specifically, with a violent raid on the very nest she was meant to call home. There is no cruelty in this, not in the way we'd apply that word to human behavior, and there is no deception in the sense of conscious intent either. It is simply the outcome of millions of years of evolutionary pressure, acting on a chemical recognition system never designed to account for the specific, narrow vulnerability a raiding species eventually learned to exploit. It's a genuinely strange, quietly unsettling reminder that even something as seemingly simple and predictable as an ant colony can conceal relationships considerably stranger than most people walking past a nest in their own yard would ever think to imagine. Had you ever heard of this kind of relationship between ant colonies before today? Does it change how you think about the ant trails in your own yard? Tell me about it in the comments below. I read every single one, and sometimes your stories become the subject of the next video. And if you've ever wondered what another small creature quietly living in your yard actually knows about your world, I think the next video might surprise you just as much as this one did. Until then, keep watching, keep wondering, and never stop paying attention to the small things.